Imagine opening a book written 1,000 years ago. Inside, you find a man discussing light in a way that sounds surprisingly similar to what you might read in a modern physics textbook. Then you meet another man standing on top of a mountain, trying to determine the size of the Earth, without a satellite, without an aircraft, and without leaving the spot where he stands. Finally, you arrive in Damascus and discover a third scholar studying the heavens. You examine his astronomical diagrams. Then, almost 2 centuries later, you encounter a geometric model strikingly similar to his in one of the most famous books ever written on astronomy. 3 stories, but the last one is the strangest. The first scholar was al-Hasan ibn al-Haytham. At a time when ancient ideas about vision and light still carried enormous influence, Ibn al-Haytham was not satisfied with simply saying, "This is what I believe." He wanted proof. He studied light, reflection, refraction, and vision. More importantly, he connected ideas to observation and experiment. UNESCO describes him as one of the pioneers of modern optics, drawing particular attention to his use of experiments to test hypotheses. The point is not to exaggerate and declare in a single sweeping sentence that he invented modern science. What is remarkable is that a man living between the 10th and 11th centuries approached questions about nature with a demanding principle. A claim is not true simply because it is famous. Test it. But wait, the second scholar attempted to measure something far larger: the Earth itself. Abu Rayhan al-Biruni lived in the 11th century. He developed a geometric method for estimating the Earth's radius using measurements related to the height of a mountain and the angle of the horizon. Modern studies in the history of mathematics still examine his method and reconstruct its geometry. No satellites, no GPS, only a mountain, a set of angles, and mathematics. But the third story is even more remarkable. In 14th-century Damascus lived an astronomer named Ibn al-Shatir. He developed mathematical models for the movement of celestial bodies and attempted to address problems within the Ptolemaic system. Then comes the detail that made historians stop and look again. An academic study published by Cambridge found that Copernicus's model for Mercury in his famous book is almost geometrically identical to the model developed by Ibn al-Shatir. The study's authors argue that the models were transmitted in some form. Yet, the historical route through which that knowledge may have traveled remains a subject of investigation and debate. Notice exactly what this means. It does not mean that we can simply say Copernicus stole from Ibn al-Shatir. That is an easy accusation, but the surviving documents do not allow us to make it so confidently. The reality is more intriguing. We have a scholar working in Damascus. We have another scholar working later in Europe. We have mathematical models that resemble one another to an astonishing degree. And we have historians who are still trying to reconstruct the path between them. Perhaps this is the real revelation. The history of science was never the story of one civilization waking up alone and inventing everything. It was an immense network. An idea emerged in one city. It was translated, copied, carried across borders. Sometimes, the name of its original author changed or disappeared. Then, centuries later, someone discovered that the story had begun somewhere else.